Hey everyone, welcome back to Cybersecurity TV. Today we're going to discuss about what is hashing. In the previous episode, we talked about what's the block cipher versus the stream cipher. So this is part of the encryption, and we're going to talk about what's the hashing, the basics of it, what different type of hashing algorithms are, what's the biggest challenge with the hashing as well. So let's get right into it. So the first thing first, what's hashing? The hash function is something that would convert the invariable input to the fixed length output. So it's different than the encryption though. So you cannot decrypt the hash. It's not something you can crack or decrypt or hack into. So that's totally different. But the main goal of this hashing is to preserve the integrity of the data. So how it works? For example, let's say you want to send a message from one place to another, to one system to another, and you want to make sure when you receive the data, or you want to make sure the integrity of the data is the same. So what you would do is you would compute the hash of the data, and you would match the hash before with the sender's hash, and if it matches, then that means the data is as is. Now you would have seen this in multiple applications. So for example, if you had to download any of the tools software, they offer the hash matching. So for example, if you go to the Tenable, right, NASA's, and you download that particular version for the desktop version, they offer this MD5 hashing or SHA SHA hashing. Then you would download any antivirus software or anything, they would always give you this particular function, because there are a lot of features out there, and you may end up downloading the malware or something. So always try to do this matching before you download or install on your system. Now, what's the main difference, right? So with the ciphers, we saw that when you want to send something from system A to system B, you encrypt using certain algorithm, AES or whatever it is, and then you decrypt at the receiver, so you get the data back in the plain text. Now, hashing is one way, as we saw. So once you hash something, it's impossible to kind of reverse it. So it's impossible to derive the plain text from the hash. So it's sort of one-way process. You cannot decrypt the hash. Now the question is, where do we use the hash? The simplest example, the application that we see on a day-to-day basis, is the password. Uh, we highly recommend, right? So whenever we do the architecture design review or the penetration test, we highly recommend that you never ever store password in the plain text. So how the passwords are stored in the database is, when the users on the sign up page provides the password will be hashed, or the hash would be computed based on the password, and the hash would be stored in the database. Now this provides benefit, because if somebody gets hold of to your database, then they are not going to receive the plain text passwords, right? So that it's just hash. So that's some benefit that you get if you ever get hacked. But the way it works is, when the next time user comes back to login, provides the username and password, the password again, the application would compute the hash on it, and it will retrieve the hash from the database. And if the hash matches, then the user login is allowed, otherwise it's not. So that's why encryption is not a good method to use for the password or the login authentication. It's always the hashing which works. Now there are two hash algorithms. One is MD5 message digest. So how it works is, it generates the data strings to protect the integrity of the data. So same thing what I said, like if you download any software, you would see the MD5 or SJ. MD5 is the most common hashing algorithm that you would see, and it produces the 128-bit string. The second example is the secure hashing algorithm, also known as SHA. There are two variations of it, SHA-1 and SHA-256. Of course, one produces 160-bit strong string, and then 256, as it sounds like, it produces 256-bit string. So irrespective of, let's say you provide the data of 350 strings, right? And if you go with the MD5, it will still produce and compress into the 128. And with SHA-1, it's going to go with the 160, and 256, it's going to go with the 256-bit string. Now, what's the biggest challenge or the problem with the hashing? It's a collision attack. And first, we need to understand what's the collision attack. So, the collision attack is something when the two pieces of the plaintext data are producing the same results. So, for example, let's say uh, my password is password 1 and it produces this C1A529, whatever hash. There's another user whose password 2, of course, it got some random hash. Now there's a password 3, which, after time, after a certain time, of course, you don't have that many random strings. So there is a possibility that it will generate the same hash as the password 1, as you can see here. Now, this is a huge problem. Because if I'm the attacker and let's say I'm trying to brute force login on facebook.com, for example, of course, I'm not saying that the Facebook has this attack possible, but let's assume. Of course, username is pretty simple. We all can easily enumerate the username of someone. So that's not a problem. For the password, let's say if I try, my password is password123, and the attacker tries password ABC123 or something. Now, in case if ABC123 produces the same hash as what meant to be password 123, then I'll be able to log in. The attacker will be able to log in and impersonate my user. So that's the biggest problem we have, and there is also a solution to that. But we're not gonna discuss the solution right now. I'm sure you guys might know about that, and I would appreciate if you guys leave me a comment with the solution. That would be something like brainstorming exercise that we all can do while sitting at home, working from home, etc. So I'm gonna end it here. I just wanted to give you guys a brief overview of what the hashing is because we just covered the ciphers, and we have also covered, I guess, some time ago the encryption as well, public key infrastructure, public key encryption, or anything. If you want any more details, let me know. I'll cover that as well. Next week I have one interesting vulnerability to demonstrate, so I'll do that. But until then, thank you so much, and I'll see you guys next time.